Hello friends, today's our topic is linear equation in two variable. Okay, before we start, let's deal some basic concepts. Uh, First of all, we should know what is mean by equation, and we should know what is the difference between equation and expression. So let's see first expression. Expression, for example, x plus y, xy plus 1. Expression means it include only variables and constants. In expression include only variable and constants, and the difference between expression and equation is that equation include equal to sign. For examples, x plus y is equal to 1. Okay, equation, for example, x plus y is equal to 1, ab plus 1 equal to 0. So main difference between expression and equation is that equation include equal to sign. Okay, so when we call it as equation in one variable, two variable or three variable, see, if any equation include number of unknown is equal to number of unknown is equal to number of variables. For example, x plus y plus 1 is equal to 0. This is equation. In this equation, two unknown is there, x and y, two unknown is there. So this is equation in two variable. Okay, equation in two variable. So one more example, x plus 2 is equal to 0. This is also equation, but in this equation one unknown is there, x. So this is equation in one variable, equation in one variable. Okay, so one more example, third, a plus b plus c equal to 0. In this third equation, three unknown is there, a plus b plus c, three unknown is there. So therefore we can call it as equation in three variable, equation in three variable. Okay, so next is when we call it as linear equation and non-linear equation. What is the difference between linear equation and non-linear equation? Okay, so first, linear or non-linear equation. Okay, so any equation of power, any equation in variable of power 1 is called it as linear equation. So for example, x plus y is equal to 4. This is one equation in two variable. In this equation, the variable x and y both of power 1. So it is linear equation. Okay, any equation of variable of power 1 we can call it as linear equation. And suppose x square plus 4 is equal to 0. So variable of power other than 1, so we can call it as non-linear equation. So this is some basic part. So now we'll start linear equation. Okay, see, linear equation means equation of line. Okay, it is a equation of line, equation of line. Okay, so first we should know what is the general form of line. Okay, general form of line, general form of line. Okay, our general form of line is ax plus by plus c is equal to 0, where x and y is the variables, a and b are the a, b, c are the constants. Okay, so in general form of line, ax plus by plus c is equal to 0, a is not equal to 0, b is not equal to 0 together. Okay, a is not equal to 0 and b is not equal to 0 together. Okay, so how to find point on a line? Okay, how to find a point if equation of line is given? Okay, so see, we already know line consists of infinitesimally many points. Okay, for example, it means that infinitesimally many points lie on a line. Okay, so suppose how to find a point when equation of line is given? For example, suppose x plus y is equal to 5. This is the given equation of line. Okay, so you can assume any real number for one variable and find the second variable. For example, see, x is equal to 0. I can substitute here x is equal to 0. So y is equal to 5. Okay, x is equal to 0. Substitute x is equal to 0 in this equation. 0 plus y is equal to 5. So y is equal to 5. So my point is P1 is 0, 5. So I can also substitute y here. Okay, so if suppose y is equal to 0, so x becomes y is equal to 0. I can substitute y is equal to 0 in x plus y is equal to 5. Okay, so x plus 0 is equal to 5. So x is equal to 5. So my point is P2 5, 0. I can substitute any real number. So one more example, x is equal to minus 2. So point becomes minus 2 plus y is equal to 5. Okay, so y is equal to 7. Okay, so my point becomes P3 minus 2, 7. Okay, so if any equation of line is given, so we can find point in this method. Okay, so I already told you line is made up of infinitesimally many points. It means infinitesimally many points lie on line. So see the general form of line, ax plus by plus c is equal to 0. I already told you a is not equal to 0, b is not equal to 0 together. Suppose a is equal to 0, case 1. Suppose I take case 1, a is equal to 0. So what will happen? 0 into x plus by plus c is equal to 0. Okay, so by plus c is equal to 0. So by is equal to minus c, y is equal to minus c by b. Y is equal to minus c by b, it means some constant k. So y is equal to constant, it is nothing but a equation of line which are parallel to x-axis. X-axis. Okay. So case 2. Suppose b is equal to 0. B is equal to 0. So substitute b is equal to 0 in general equation of line. So ax plus 0 into y plus c is equal to 0. Okay, so ax plus c is equal to 0. Ax plus c is equal to 0. So ax is equal to minus c, x is equal to minus c by a. It means x is equal to minus c by a, it means some constant k. So this is, we already know this is also equation of line which is parallel to y-axis. Equation of line parallel to y-axis. And our third case, if suppose we'll take a is equal to 0, b is equal to 0 together. So our general equation of line becomes ax plus by plus c is equal to 0. So 0 into x plus 0 into y plus c is equal to 0. So c is equal to 0. Okay, it means our equation becomes vanish. Equation vanish. Okay. For that reason we can't take a is equal to 0, b is equal to 0 together. Okay, so now orientation of two given straight line, in a plane. So our next topic is orientation of two given straight line in a plane. Orientation of two given straight line in a plane. In a plane. Okay. In this topic, three cases is there. Number 1, suppose two lines is there. L1 is equal to a1x plus b1y plus c1 is equal to 0, and L2 is equal to a2x plus b2y plus c2 is equal to 0. So two lines is there. Case 1, three cases is there. Case 1, suppose this line is parallel to each other. Okay, it means no common point in these two lines. So number 1, parallel lines, no common point. So case 1. Case 2, these two lines is also coincident. Then, so coincident, it means finite common point. And case 3, these two are intersecting lines. Intersecting lines, it means only one common point is there. So in case 1, so parallel lines, one condition is there. The condition is A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. It means the coefficient of first variable, ratio of coefficient of first variable is equal to ratio of coefficient of second variable is not equal to ratio of constant. So if this condition is satisfied, so the two lines becomes parallel. We can call it as parallel line. The two lines present in plane are the parallel lines. Okay, and in coincident lines, if the lines present in plane, these are coincident lines, so the condition is A1 by A2 is equal to B1 by B2 is equal to C1 by C2. It means coefficient of first variable, ratio of coefficient of first variable is equal to ratio of coefficient of second variable is equal to ratio of constant. So we can call it as coincident lines. Infinite common point in this between these two lines. Okay, case 3, intersecting lines. So when we call it as intersecting lines, when the when this condition is satisfied, this condition A1 by A2 is not equal to B1 by B2. It means the coefficient, ratio of coefficient of first variable is not equal to ratio of coefficient of second variable, then we can call it as intersecting lines. Okay, intersecting lines. We can give examples. For example, suppose 2x plus 3y plus 3 is equal to 0 and 4x plus 6y plus 5 is equal to 0. So in this equation, see, coefficient of first ratio of coefficient of first variable is equal to ratio of coefficient of second variable is not equal to the ratio of constant. So this is the example of parallel lines. So next example of coincident lines. So x plus 2y plus 3 is equal to 0 and 2x plus 4y plus 6 is equal to 0. So in this equation, see, the ratio of coefficient of first variable is equal to the ratio of coefficient of second variable is also equal to the ratio of coefficient ratio of constant. So we can call it as coincident lines. Okay, and last, for example, x plus 3y plus 4 is equal to 0 and 2x plus y plus 3 is equal to 0. So, see in this example, coefficient of ratio of coefficient of first variable is not equal to ratio of coefficient of second variable. So, in this example we can call it as intersecting lines. Okay, so these are intersecting lines. Okay, so this is the orientation of two given straight lines in a plane. So in three cases is there. Number one, parallel lines, no common point is there. Second, coincident line, infinitesimally many common point is there. And third is intersecting lines, only one common point is there. And these are their conditions. For example, parallel lines a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. Next, coincident lines a1 by a2 is equal to b1 by b2 is equal to c1 by c2. And third is intersecting lines. So a1 by a2 is not equal to b1 by b2. So this is the orientation of two given straight lines in a plane. Okay. So now we'll discuss simultaneous linear equation. Okay. Simultaneous linear equation. Okay, simultaneous linear equation. So it means method of solving linear equation. In this topic, two main methods of solving linear equation. Number one is algebraic method and number two is graphical method. Number one is algebraic method and second is graphical method. Okay. So in algebraic method, three sub methods. Number one, in algebraic method, three sub methods for solving linear equation. Number one is elimination method. Number two, substitution. Number two, substitution method. And number three is cross multiplication method. Number three, cross multiplication method. So simultaneous linear equation, there are major two methods for solving linear equation. Number one, algebraic method. Number two, graphical method. So in algebraic method, there are three sub methods. Number one, elimination method, substitution method and cross multiplication method. So let's see first elimination method. Okay. First, elimination method. Okay. So in this method, first we equal the coefficient of one variable in both equation by multiplying one by multiplying a equation with suitable constant. Okay, so first of all, first in this equation, in this method, first we equal the coefficient of one variable in both equation by multiplying the equation with suitable constant. Suitable constant. Okay, so it means in elimination method, first we equal the coefficient of one variable in both the equation by multiplying the equation with suitable constant. Okay, and next then add or subtract these two equation and eliminate one variable. So this is the elimination method. So for example, so let's see example first. Suppose two line equation is there, 2x plus 3y is equal to 5, or 3x plus 4y is equal to 6. So two line equation is there, so we have to solve the linear equation by method of elimination. So first of all, see the definition. The first we equal the coefficient of one variable in both the equation by multiplying the equation with suitable constant. So see, suppose the coefficient of x is 2, and in equation 1 the coefficient of x is 2, and equation 2 the coefficient of x is 3. So we have to first of all we equal the coefficient of one variable, and for that reason we have to multiply the equation with suitable constant. So we have to multiply equation first or equation 2. So we have to multiply equation 1 by 3 and